Uniform circular motion. A particle moves in a circle with constant speed, then it is called uniform circular motion. In this case, v equal to constant since dv by dt equal to 0. Since we have acceleration, a vector equals to minus omega square r into er vector plus dv by dt t vector. So in the case of uniform circular motion, dv by dt equals to 0, hence a vector equals to minus omega square r into er vector, or a equals to mode of a vector omega square r equals to v square by r. This acceleration is directed toward the center and is called centripetal acceleration. Non-uniform circular motion. If the speed of the particle moving in a circle is not constant, then the acceleration has both the radial and the tangential component, as the motion is non-uniform circular motion, and the motion is non-uniform circular motion. Now we have ar equal to minus omega square r equal to minus b square by s, radial acceleration, and at equal to dv by dt, tangential acceleration. Hence magnitude of net acceleration a equal to under root ar square plus at square under root v square by r का whole square plus dv by dt to the whole square. If resultant acceleration makes beta angle with radial component, then tan beta equals to dv by dt divided by v square by r. Hence beta equals to tan inverse dv by dt by v square by r. Question: a particle moves in a circle of radius 1 cm at a speed of given by v equals to 2.0 into t, where v is centimeter per second, t in second. A. Find the radial acceleration of the particle at t equal to 1 second. B. Find the tangential acceleration at t equal to 1 second. C. Find the magnitude of acceleration at t equal to 1 second. Solution. Radial acceleration ar equals to v square by r equals to 2 into t का whole square divided by r equals to 4t square by r. Now at t equal to 1 second, ar equal to 4 into 1 square by 1 equal to 4 centimeter per second square. B. Tangential acceleration at t equals to dv by dt equals to d by dt 2t equals to 2 centimeter per second square independent of time. At t equal to 1 second, at t equal to 2 centimeter per second square. C. Net acceleration a equals to under root ar square plus at square under root 4 square plus 2 square centimeter per second square equal to under root 16 plus 4 centimeter per second square under root 20 centimeter per second square equals to 2 under root 5 centimeter per second square. RPM or RPS. We have 1 RPM is equals to 1 rotation or 1 revolution per minute, equals to 1 rotation by 1 minute equals to 1 rotation by 60 seconds, because 1 minute equals to 60 seconds, or equals to 1 by 60 rotation per second, or equals to 1 by 60 rotation per second, or equals to 1 by 60 RPS. That is 1 RPM is equal to 1 by 60 RPS, or 1 RPS equals to 60 RPM. Angle covered in 1 rotation is 2 pi. Angle covered in 2 rotation is 2 into 2 pi. Similarly, angle covered in n rotation is n into 2 pi, or equal to 2 pi n. Thus, total angular displacement in n rotation is theta equals to 2 pi n. If n rotation is made in time t, then angular velocity omega equals to theta by t equals to 2 pi n by t equals to 2 pi into n by t equals to 2 pi n, where this n is the This n is called angular frequency or number of rotation made per minute or per second. A particle in circular motion moves with 1500 rpm. Find a angular displacement of particle in 5 seconds, a speed of the particle, the radial acceleration of the particle, resultant acceleration of the particle. The radius of circle is 1 by 50 centimeter. Given n, that is angular frequency 1500 rpm. Now this can be changed into rps. 1500 into 1 by 60 rps. So 1 by 56 rps. Hence angular speed of particle omega equals to 2 pi n. 2 pi into 1 by 50 by 6 radian per second. And angular displacement theta equals to omega into t. So 2 pi by 150 into 6 into 5 radian answer. Hence the speed of the particle v equals to omega, that is linear speed or tangential speed. V equals to omega 2 pi by 6 into 1 by 50 into 1 by 15 meter per second. Pi by 3 into 10 meter per second equals to 10 pi by 3 meter per second. AR equals to v square by I r, तो 10 pi by 3 का होल स्क्वायर by 1 by 15 equals to 15 into 100 pi square by 9 meter per second square, and AT equal to dv by dt equal to 0 as v speed is constant. Hence resultant acceleration A equals to under root AR square equals to AR equals to 1500 by 9 pi square meter per second square answer. Use of angular kinematical equation in rotatory or revolutionary motion. We have theta equals to omega naught t plus half alpha into t square. We note that theta is the angular displacement, omega naught is the initial angular velocity, alpha is the angular acceleration, and t is the time interval. For example, the initial angular velocity of particle is 5 radian per second and its angular acceleration is 10 radian per second square. Then find the angular displacement of particle in t equals to 4 seconds. Here theta equals to what? Omega not given 5 radian per second alpha equal to 10 radian per t equal to 4 seconds. Using this formula, theta equals to omega naught t plus half alpha t square. 5 into 4 plus 1 by 2, 10 into 4 square equals to 20 plus 5 into 16 equals to 100 radian per second. Not per second because angular displacement, so 100 radian answer. In the above problem, find angular velocity of the particle. Solution: omega equals to omega naught plus alpha t. We have omega naught given 5 plus 10, alpha equals to 10 into 4, so 45 radian per second. The angular velocity of a particle changes from 5 radian per second to 45 radian per second, covering an angular displacement of 100 radian. Find the angular acceleration of the particle. Solution: here given omega naught, that is initial angular velocity 5 radian per second and final angular velocity 45 radian per second. And angular displacement is 100 radian. Now we have omega square equals to omega naught square plus 2 alpha into theta. This implies 2 alpha theta equals to omega square minus omega naught square. Hence alpha equals to omega square minus omega naught square by 2 theta. 45 square minus 5 square by 2 into 100. This gives 45 minus 5 and 45 plus 5 by 200 equals to 14 to 50 by 200 equals to 10 radian per second square answer. Centripetal acceleration. Oh no, sorry. Centripetal force. When a particle revolves in a circle with constant speed, the particle experience a force toward the center, this force is called centripetal force. And given by F equals to m into a r equal to mv square by r equal to m omega square r. This force is provided by some other forces like friction force, gravitation, tension to revolve the particle in circuit. Example, in Bohr model, in the ground state, the electron goes around the proton in a circle of radius 5.3 into 10 to the power minus 11 meter. Find the speed of the electron given a mass of electron equals to 9.1 into 10 to the power minus 31 kg and QE, that is charge on electron, is 1.6 into 10 to the power minus 90 coulomb. Here centripetal force is provided by Coulomb attraction force between the electron and proton. If V be the speed of the electron, then centripetal force equals to Coulomb force. This apply me into V square by R equals to 1 by 4 pi epsilon naught Q into Qp by R square, where Q is the charge on electron or Qp is the charge on proton. R is the radius of the revolution. This implies V square equal to 1 by 4 epsilon naught Q into Qp divided by Mr. Hence, this implies V equal to under root 4 pi Q into Qp by Mr. Putting all the value, 1 by 4 pi epsilon naught is 9 into 10 to the power 9 in SI unit, and Q is 1.6 into 10 to the power minus 19, and also Qp is also 1.6 into 10 to the power minus 19. Mass of electron is 9.1 into 10 to the power minus 31, and the radius is given 5.3 into 10 to the power minus 11. So solving this, we get the answer, required answer. This is shown a blade of the fan on which a particle of mass m is resting, and the radius is r. Now this force, to revolve this particle in the circle, the force is provided by force of friction. So F will be equal to Fc equal to mv square by r. Now n is given 1500 rpm, so we can first change into rps, 1500 by 60 rps, and angular velocity will be 2 pi n, that is angular frequency. This is angular frequency. So 2 pi 500 by 60 radian per second, or 50 pi radian per second. This is the free body diagram of this particle. Normally this reaction force, this is rate of particle, and this is the frictional force. Again, V equal to omega to 50 pi into 0.6 equal to 30 pi meter per second, and Fc will be mv square by r given by this value, and equals to 3 pi square by 14.78. The surface of blade exerts this force. The particle exerts same force, that is 14.78 Newton along blade surface. Solving this problem in rotating disc, FBD of particle is shown. This is the particle and this is rotating with acceleration, that is centripetal, with linear speed v. So centripetal acceleration will be mv square by r. The free body diagram of the particle is shown. Because we are solving the problem in disk frame, so we have to apply a pseudo force opposite to the centripetal force, that is F equal to mv square by r, and there will be a, from seeing on the from the disk frame, we see that body experiences a friction force in this direction. So we have normally and vertically upward, and weight in the vertically downward. We know that F equal to mu r equal to mg, force of friction, or F equal to mg square r pseudo force. Now for particle to be in rest, F should be greater than equal to Fp, or this will like mu mg is greater than equal to mv square by, or mu is greater than equal to v square by rg. Question 1. Now n is given 33 into 1 by 3 rpm, 100 by 3 rpm, solving within 100 by 3 into 60 rps, or omega equal to that is angular velocity 2 pi n, 2 pi 100 by 3 into 60 equal to 10 pi by 9 radian per second. Again given r equal to 10 c equal to 0.1 meter in SI unit, or v equal to omega 0.1 10 pi by 9 into meter per second 5 by 9 meter per second. Now from mu1 mu should be greater than equal to pi square by 81 into 0.1 into 10, or pi square by 81. Hence mu greater than equal to pi square by 81. Hence mu minimum equals to pi square by 81. Answer 30. In ground frame, FBD of Bob is as shown in the figure. This is theta, then this will be theta, tension will be tension in the string is in this component will be t cos theta, in this direction t sin theta, and mg. Circular motion of bob is provided by t sin theta, hence t sin theta equal to mv square by r. This is equation 1. Given a speed v equal to 36 km per hour, or 36 into 5 by 18 meter per second, about 10 meter per second. And again vertically it is in rate, so t cos theta will be equal to mg, or so t cos theta equal to mg equation 2. Dividing 1 by 2, tan theta equal to mv square by r into 1 by mg, or v square by rg. Putting the value we get 1. So theta equal to tan inverse 1 equal to 45 to the answer. So this is the situation of different types of, we have solved different types of problem in the circular motion. There will be many different problem again. In the next lecture we will discuss about the circular turning and banking of roads, and we will see how the problem is solved related to the banking or turning of roads. So goodbye from the ffbmd. That's all. Thank you.